go back and do the statement again, and then check that again. It will keep doing that until that condition becomes false. Okay? Therefore, actually these two are so similar. The only difference is that regardless of the condition, this statement will be executed at least once. The very first time is always executed. For the while loop, if the condition is false, these never get executed. But when the initial conditions are true, the two loops, the do loop and do while loop, the while loop and the do while loop are exactly the same. Okay, so that's the only difference. The only difference is whether this statement get executed once or not, first time. Okay. All right, another very commonly used loop, especially for calculation, is the for loop. The syntax of the for loop is a little bit more complex than the other one. The parenthesis inside has three things. First is initialization, condition, and then increment or decrement, okay? And then statement. Oops. Okay, for the do loop and while loop, again, I emphasize that there's no semicolon after do, and there's one here. But for the while loop, you write right here and block, you don't put a semicolon there. The same reason as the if statement, okay? Okay, how is this for loop executed? The program will first execute that initialization, and then it will check the condition. If the condition is true, it will execute that statement. Once this is executed, then it will come back to do here. It usually changes the index, either increase its value or decrease its value. And then check the condition again. If it's true, do that. Then go to the increment, decrement, and then check the condition and do that. Keep doing like this. Okay? Okay, let's say for example, a block of code for integer and initialize it to 10. And then when n is larger than 0, and then semicolon, and then n minus minus. Say C out, and that's less than, comma, semicolon, and then C out, left of slash n. Okay, this block of code, what will be the output? It's the same. It's 10, 9, 8, up to 1, and then lift off. Okay? Because the first time this is executed, n has the value of 10, and the condition is checked. 10, of course, is larger than 0. So this got executed. You output the value of 10 on the screen, and then a comma. And after that, the increment decrement is executed. So n, the value of n is reduced by 1. So it has the value of 9. And then check the condition is still true. So this is get executed. But this time, this value is 9. So 9 is output on the screen, and then a comma. and then n value becomes 8, and then check that it's still true. So you keep doing that until n becomes 0. This is no longer true, so you will get out of the for loop and execute the last statement, which is lift off. Therefore, this for block achieved exactly the same as the previous for loop, while loop. Okay. I like to use these. If possible, I can use for loop or while loop. I always use for loop because it explicitly forces you to do something with the index, usually here. So you're not likely to forget it. For the while loop, you need to do something with the index inside. Sometimes you forget it, and that becomes very bad. Okay, you have a dead loop. Okay, and also for this program block, whether you write it as n minus minus or minus minus n, the result is exactly the same. Okay, and also don't forget to do not put a semicolon after this way. If you put a semicolon here, it becomes an empty for loop, okay? And this will be executed once, regardless of the condition. There's also a bunch of jump statements. One big statement and one jump statement is called break. Whenever you put a break in a loop statement, at that point, when break is encountered, it immediately stops the looping and get out of it. Okay, it will break the loop. I would say, if possible, avoid it. Okay, because your initial intention to do a loop is to do something, right? A looping. But why would you break it? If you use a break, usually you should put an if statement in front. Okay, judging a particular condition. If it's true, then break it. A blank statement is usually can be avoided. Okay, and it usually doesn't make much sense to me to use a blank statement. So avoid it if possible. Another jump statement is go-to. Go-to statement is a very dangerous statement. Whenever you encounter that, you will just go to wherever you want it. You put a label in any place, it will go to that place. Okay. And again, my advice is avoid go-to at any price. At any cost, if you could, okay? Why? Because when you write, you reduce the readability of a program. When you write a program, this is starting point. You have one block. You may do some looping inside the block and something, and then you want to go to another block, and then another block. Sometimes you have the branches, something like that. Okay, they converge and then go on. But in general, you know how the program flows. If here you have a go-to statement, lowercase, okay, sorry. You don't know how the structure is now. You can go to any places that you want. You make the program unstructured. An unstructured program is difficult to read and to maintain. Okay? So, if possible, you always try to avoid the go-to statement. And in this class, for FEM program, you should never use go-to statement because there's no need for that. Okay? And usually when I look at a program, if there are a lot of go-to statement, I would say this is not a very good program. You should rewrite it. These four for loops, while loop, and do while loops, they are structured in the sense that you know how things move. Okay, what is the flow of the execution? And it is limited to a certain state. You will not be out of control. Go-to statement make things out of control. Okay, that is the loop statement. Next, I'd like to talk about a very important concept, functions. This is chapter 9. Okay, again, I will introduce the concept of function by example. Let's say I define a function by the integer type. The function name is called addition. It's going to take two variables, let's say two integers. The first one a, the second one b, okay, and close parenthesis. And inside the body, we will define another integer r. And r is assigned the value of a plus b. And then I'm going to return the value of r. Okay, that is a complete defined function called addition. And by looking at that, you know what it's going to achieve. It's very simple. It takes one value, takes another value, and add them together, and return the sum of the two values, okay, to the calling place. Of course, this function will achieve the addition of two numbers. Okay, how to use a function? Now, inside, let's say we're going to call a function in the main program. I'm going to call integer z, and then call the function. Calling a function is simple. Just put the function name, addition, and then check how many variables it takes. It takes two variables, okay? Let's say we want to find the sum of 3 and 5. Well, we can do that, but after the execution, the value is here, it's not recorded. What we really want to do is actually, I forgot to write it. Z is assigned the value of addition function, which takes two variables, 3 and 5. Okay? Okay. The statement here, it will execute the function and put 3 into that place, 5 into that place, and these two numbers get summed together and returned. Now, these return r here, we'll put this value and carry the value. The value will be carried by the function name, addition, not by r. Okay? Here, in the calling place, that function will carry this return value. Okay? The reason we should not, r is irrelevant here because it's just local. All these three variables, a, b, and r, they are local to the function. They are invisible outside the function. Okay? Therefore, you don't need to, if you say integer a is equal to 1, I declared integer a equal, initialize the value to 1, and then integer b initialize value to 2, and then comma. Okay? If you put a statement like that, you need to realize that these a and this b, they are only local to the function main. It has nothing to do with that a and b here. Okay? Therefore, when you call the function, it is the value in the variable location that will be put in. So 3 will put here, 5 will be put here. It's not a, even though this is called A, which has the value of 1, B has the value of 2. These 1 and 2 are not put here, because these A, B are local to that. And these A, B are local to that function. Okay? The exchange of values is only through positions. So the first position has the value 3. The second position has the value 5. This is also called call by values. Okay? Okay, once we've done that, now we can output that C out less than Z equal C out Z, and then we can say /n, and then return 0. That will complete the main program. So what the program does will to perform an addition of 3 and 5 and put the value in Z and output Z. Okay? And of course, for a simple function like that, you may be even simpler to write it 3 plus 5 here because it's the same thing. But for a more complex calculation, you would like to use functions because it makes the program more modularized. All the calculations, the details of the calculation is inside. And you only care about the result. Okay? So functions make a program more readable and more modularized, more structured. This is very good. For example, if we want to invert a matrix, okay, that can be a huge undertaking. Inversion of a matrix is not so trivial. That program can be very long. And inexperienced programmer will write every code in the main function. But a more experienced programmer will always write the inversion of a matrix into a function and just code it in the main program. And then another advantage of a function is that you can call it repeatedly. Anywhere you need invert a matrix, just call that function. Okay? I remember the very first program that I wrote when I was doing my PhD. I put everything in the main function. It gets thousands of lines and it's very difficult to read, to maintain. As I later become more experienced, I try to modularize it. So as a frequently used calculation will be put into a function, okay, or subroutine if you use Fortran. And then the main function should be rather high level and rather short. Just open the input, file, open the output file, and call the execution or something, and write the result and end. And then inside that you can do more modularized tasks. Okay, so functions are very, very useful. The thing I like to emphasize is that this is called by values. Okay, only the values will be used here. If in this case I define A and B, and I put A here, okay, if this is 5, 3 and 5, what will be the value of Z when you execute that up to that point? You will see Z equals 8 on the screen, right? Now, if I put A here, B here, what will be the output? The output will be Z equals 3, right? And then, if I put this one, C out, A equal A, what do you think you will see A value is? It will be 1, right? Now, if I modify that program here, A change it to 10 inside the function, and then I execute that again, what do you think the A value is? Still be 1. Because A is local to that. This A is local to that function. It's inside. Okay? The exchange of the A value is only by value. So a copy of the A, the value of 1 is put here, A itself, the value of A in this part, will not be affected by anything here. Okay? This is called by values. And sometimes you want the program to modify the variables here directly. You can do that, which is called call by reference. Okay? If you want to do that, then what you need to do is use call by reference. Okay, the syntax is this. Addition, integer, and then put this, you call it ampersand, A, and then integer ampersand B. If you do that, this is called by reference. Then whatever variable, when you call the function and put it here, the variable itself will be used inside the function to execute things. Okay? Let's say we defined it like this. Okay? Let me now modify this program. I think I better use the red pen here. I put an ampersand here. And then this ampersand here. Okay, the rest is the same. After I execute it, this time is called by reference, okay? If I do call by reference, up to this point, what do you think the output will be? Okay, here z is equal to, what will the value of z? 3, very good. Because A is 1, B is 2, so A is put in here, A itself is used here, and go inside, B itself is here. So at that point, A has the value of 1, B has the value of 2, they are summed together, which is 3, and put it here, and return. But at that point, A is changed to 10. So what do you think this A will be?
Should be 10.
It will be 10. Okay? Because the value itself, because it's called by reference, A itself is being used in the function. And here it's changed. Alright, so for this particular program, if you use call by reference, the output here A will be 10. If you don't use it, you use call by value, here A will be 1 still. Okay? So that illustrates the difference between call by values and call